Students, we have another lesson to add to our content for this unit. Remember that our test is exactly a week from today. We're going to be taking our test over this unit. And this lesson, I'm hesitant to say it, but it should be shorter. We have one idea that I want to get across in it. The last video we did a couple examples of hypothesis testing. It's likely that I'll go back and work the other two examples that I wanted to, but today I just want to go ahead and get some new information in your minds, and we're going to work a couple questions on the problem set. So that's going to be the game plan for this video. Let's get into it. Okay, so in your notes, if you would, you can draw a line. And we're going to continue talking about these hypothesis tests, but we're going to be relating them to confidence intervals, okay? We're going to be relating them to confidence intervals. And what I'm going to explain here, we're going to have an example for this, and this is one of my favorite examples. Since I've started teaching stats, this was a very interesting situation that happened in 2018, the class of 19. Yes, that's who it was. I had two bowlers, and maybe you guys remember these students as Matthew Dominy and Gavin McCune. They were seniors, and they were both in the same class, in a stats class in my fourth period back 2 years ago. And they were very competitive with each other. And so as soon as I had taught this idea of hypothesis tests, and I said, hey guys, this is basically a way to win an argument with math, okay? You can use the words, well, statistically speaking, I am blank, right? Or this is blank. And that's the whole point of this. And hopefully that's a way that you've been thinking about this when we did those examples with the potatoes, and they had to ship the potato truck away or keep it, right? Or the fish, was the aquatic life at risk in that river? Like, those are some real world situations that, it's very important to have evidence besides, just looking at it, or, you have a very scientific sort of statistical approach to a situation. And that's what happened here. So as soon as I was explaining this process, Matthew had said, so you're telling me I can prove that Gavin is wrong based on using statistics? And I was like, yes, of course, that you could do that, right? So we're not really going to be concerned about the checks here as far as like randomness, or we'll talk about it a little bit, right? But here's what happened. Matthew has had the claim, or he had the claim, that he was a 200, like on average, he would bowl a 200. That's what his claim was, right? So right away, what does that sound like? It sounds like a hypothesis. So we're going to start with this example. We're going to start with, this is part one, right? Which is state the hypotheses. So one, we have a null and alternate hypothesis, right? Okay. So Matthew had said, I am on average, 200 is going to be my average score for bowling, which is very impressive, right? Imagine mine is probably less than 100. So, and then if any of you know about bowling, you know that, this is a difficult score to achieve, but, if you're playing competitively, like for our school, this is what you're going to see usually in the high school level. I don't know anything about college bowling, but I know that Matthew went on to bowl for college. Anyway, Gavin's claim was like, no, you're less than that. You don't bowl a 200, you're below that. So we have a competing claim, right? That's our alternate hypothesis, okay? Here's what happened. I'll write this out in bullet points. Matthew, actually, this is what happened. He bowled 10 games, okay? So you can imagine this. I was explaining this to the in-person students the other day. I play like 2 or 3 whenever I go bowl, and it feels like it takes forever. He was by himself, he said, but he came in with it was Smyrna Bowling Alley, and he came in with a sheet of data, right? So he bowled 10 games, and he got his scores for each one of those. And it turned out that he bowled 10 games, so the mean of the 10 games was 91.21. Okay. So, and you can imagine when he brought it in, I was like, dude, you bowled 10 games? And I was like, how long did that take you? He said, probably an hour or so, And for him, it was, practice, I guess, kind of. He's trying to be competitive, but you imagine he just keeps grabbing the balls and just keeps throwing them down the line nonstop for 10 games. I guess that's what you do when you're a competitive bowler, but it's still kind of shocking to imagine playing that much. But yeah, 191.21. So right away, and if you've learned anything from this chapter, when you look at this, and initially when we began, you may think, oh, well, Gavin is right. Matthew is below, this score is below 200, so that means Gavin's correct, okay? But we've learned in this chapter that just because it's below doesn't mean it's significant, right? We have this range where you can be below or even above, and we have to see, could this score have just happened randomly? Is it far away enough from this 200 over here to be what we would call significant? Well, he also had a standard deviation. So standard deviation of 17.21. Okay, that was his deviation between those 10 games. So all of that's going to be important for when we're going to be creating the confidence interval. That's what we did last chapter. We're going to go ahead and talk about we'll talk about the checks here. Was this random? Oh, I'm going to type them all out. Random, 10%, normal. Okay. So obviously this is going to be random. We assume that each game is going to be sort of we almost call it a random sample of just games in the long term. Now, they were back to back to back to back, but if you think about it, we could have, that was the data we needed there, that we could get. You could argue that it's not random enough and that we would want to see like random matches that he had already played throughout, right? But this is enough, we'll just say, in the long run of all the matches he's going to play for his entire life, right? Or all the games, we'll assume that this is mostly random, right? How can you, besides going back and like sampling games that he's already played, when we're gathering new data, this is as good as we can do, right? 10%, sure. I'm sure he played 10. I'm sure he's played over 100 games of bowling in his career, right? And he's got many more ahead of him. So yeah, in the long run of process, yes. But also, one game to the next shouldn't really affect anything, right? One bowl should not, one game, the outcome should not affect the next game, or it shouldn't necessarily. Sort of like free throws. Free throws are independent, is what we'd say, okay? Normal, now this one's questionable. We had talked about in the last video, we don't have, this is X bar, by the way, I forgot to mention that. If that wasn't obvious, we used mean. So we don't know if n greater than or equal to 30, right? Okay, and then we don't know if the population is normal. I would say mostly for statistics like this, you're usually going to have a normal distribution. Like there is an average that exists, and usually you're going to be above and below that, okay? But we don't have the graph, but for example's sake, we're going to say this is normal. This is where Gavin could have said, well, we need more data, right, in his argument. But for the sake of example, this was still, we're going to say that it's okay for now, okay? Now, if we wanted to run a significance test, but I'm going to say we're going to be doing this with a confidence interval. Okay, so significance test. We're going to run one of those. AP students, I'm going to just use my calculator to run this. But what type of test are we going to be using? We know it's X bar. So are we going to run t-test, or one prop test. Well, this would be a t-test, right? So AP, you would have to calculate the statistic, or the test statistic, and use the table. You'd use your this T table here for that. Dual credit students, you don't need to worry about that. We can of course use our calculator to run this test, and that's what we're going to do. So menu, statistics, stat tests, we want a t-test. Now we actually have the statistics. So we're going to select that, and the null hypothesis is 200, mean is 191.21, standard deviation is 17.21, n was 10, right? 10 games, and then Gavin is saying it's less than, so we have this less than symbol. Okay, so we run this t-test, and we get this p-value here. Okay, so 0.07. Okay, so p-value equals 0.07. That's good enough. Yeah, 0.07. Okay, so this would be step 3, right? That's what we're on here. We ran the test, and then we interpret the results, right? Well, we don't know what alpha is. In general, for just everyday occurrences and on a test, if you don't see it or if it's not stated, alpha is going to be 0.05. Okay, when you're running these tests. So that's something you definitely need to remember in case you see an example like that. That could definitely happen on the test or on the worksheet that's due Friday. So we're going to say alpha. So is this significant based on this? Is the p-value low enough to reject the null hypothesis? No. So we're going to say not significant. We're not going to write out a huge descriptor here, but we are going to say p-value is less than or greater than doing that alpha. Okay, and we're not going to write up a big description, but basically what the method we have is or the method we've been using is saying, okay, there's not evidence to say that Matthew's not a bowler. Okay, but let's talk about a confidence interval. So I want to create a 95% confidence interval. Spell. Okay, created 95% confidence interval. All right, so how do we do that? Well, we would have to find the critical value for 95%, the standard error, all of that. I am going to speed this up though and use the Inspire to do this. Menu, stats, confidence intervals. It's going to be a T interval this time. And these T intervals, and you'll notice how these, and we're relating these confidence intervals to hypothesis tests right now in this lesson. And these T intervals do the same thing as the t-test. We use the same tables. We have the stats, so we're going to type all this in. 191.21, x is 17.21, n is 10, 95%. Here's the interval right here. So it's lower 178.8, and I'll round to 2 places. So 178.9 is what we'll say. So 178.9, and then 203.5. We'll round to one place. 203.5. There's our interval. Okay. So the question is this: looking at this interval here, and you need to make sure you have this written. Looking at this interval, how would I look at that and know that this is significant, or this would be not significant? How would I know that this p-value, because these go hand in hand, by the way, this p-value here and this interval. How would I know looking at this that the p-value would be too large, right? Or it'd be bigger than alpha of 0.05. Okay. Well, if you notice this, if we compare this to this 200, what do we notice about this 200? Well, it's inside of that interval. Okay. That is going to be like the big takeaway from the lesson today, is that confidence intervals, if that null hypothesis falls within the confidence interval here, it's going to be not significant. But if it's outside of it, it is significant. So let's draw a a normal curve above here, okay? So I want everybody in your notes, you don't have to be above, but just somewhere, draw yourself a normal curve, okay? The center is going to be the claim, right? This is going to be mu from the null hypothesis. This is Matthew's claim, okay? We have this value, and I don't know the standard deviations of this. We're not really worried about that, but we have the idea that mean that he got is below it right here. And this would be 191.21. And then we have this boundary going above. Okay, so probably right here-ish and below, equally distanced. And I'm going to put some like tick marks here. This is sort of our interval, like what we saw last chapter, those intervals. And we're seeing that this interval actually captures that parameter. That's what Matthew said, 200. And it is possible, based on a sample, that his true mean, we're 95% confident that his true bowling mean is in this red interval, okay? This is sort of bringing back those ideas from last chapter as well. So 203.5 here, and this is 178.9. So make sure you've got that example in your notes. Then we're going to write down some rules. But this is the whole concept. Now, if this was shifted down, let's say he did if this was a 170, or 187 or something like that, that would cause this to shift over, right? And if this, and I'm going to draw a line through it, dotted or dashed. If this line here did not go through that red line, it would be significant because it would fall outside of this red interval. By the way, everything outside of this, from here and here, okay, is what we would call alpha, or we would call it, and those that are in dual credit, you would saw that this is alpha divided by 2, alpha divided by 2. So combined, this is that 5%. That's what this is right here, okay? So it's both of these added together. So that's what we're saying. When this p-value is larger than alpha, that means it's falling in that red interval. Okay, that's what that means. So hopefully this concept makes some sense. By no means is it a simple idea, but hopefully it's sort of making some sense. So let's write down some rules. Really the general statement for these confidence intervals. If the parameter, I'm going to say null hypothesis value is within the confidence interval, or I'll say outside, we'll start with that, outside of the confidence interval, then we reject HO at alpha equals 1 minus C%. I'll put this C% equals confidence level. Now, we've already described how this confidence level works and how it relates to alpha. You'll notice that if I add the alpha with confidence level, they add to 100. So that's what this is. They go hand in hand, and both of these chapters tie together because you can use a confidence interval to run a hypothesis test. Okay. Next, we're pretty much going to write the exact same thing. I'm going to copy and paste. We're going to say is within. So if the parameter, okay, the null hypothesis value is within the confidence interval, we fail to reject HO at alpha equals 1 minus C%. But we already know what the C% is. That's the main idea. All right, so I'm 20 minutes in. We're just going to work a couple examples in the problem set. And let's see how you do with those. Okay. So I've got the dual credit and the AP problem sets here. So for dual credit, we're going to be doing, this is the page 11 on there. You should be able to work all of these here. We're not going to do 45 in this video, but I'm going to work the rest of them. Dual credit students, this is page 7 on here. Numbers 30, we're going to do 34 through 37. We're going to do all of these, okay? So AP students, you can look on yours. I'm going to be working the questions on here. So let's go ahead and talk through these. So number 34, it says you construct a 95% confidence interval for a mean, find it to be 1.1 plus or minus 0.8. Which of the following is true? Okay, so we have all of these items here. I'm actually going to pause the video and I want you guys to submit an answer here. Okay, I want you guys to try this one first. If you want to pause and try to work them all, that's fine, and then you can just answer straight through, but I will be pausing for each one of these 4 questions for you to try to work. So I'll go ahead and pause this. Okay, so right out the gate, I'm getting rid of E because we know that we can run a hypothesis test now with a confidence interval. We just did it, right? That's what we did with on the last page here, right? We ran the confidence interval or the hypothesis test using a confidence interval to confirm the results, okay? We, of course, did a normal significance test, but a confidence interval will be okay to run a test as well. First thing you should have done is created the actual interval. So I'm going to do that over here. I'm going to do it in red, okay? So the interval itself is, we go 1.1 plus or minus 0.8. So we'll do the lower boundaries 0.3, upper boundaries 1.9. Okay. Now we're looking at these answer choices, and what we're looking for is if the value's inside, we fail to reject. If it's outside, we reject. So we look at A, 1.2, null hypothesis. That's in there, so we wouldn't reject it. Let's see what it says. It says would reject HO at 0.5 level. No, not reject it. Okay. B, 1.1, is that in this interval? Yes. Hopefully it says fail to reject. It doesn't. It says we reject, so that's not it either. Okay. 0 is not in this interval. Okay. So a test of the hypotheses mu of 0 equals 0 would reject HO at alpha 0.5. Yes, and we know it's 0.05 because it's a 95% interval. It's 1 minus C%. Yes. All 3 tests would reject? No. C is the correct answer. Okay. All right, perfect. And try 35. I'll pause and let you submit an answer for number 35 here. Okay. So you've had a chance to answer it. We wish to test the hypothesis. Mu equals 5 versus... there's the alternate, not equal 5, based on an SRS of size n from a normal population. So we're getting all the checks here. I calculated a 95% confidence interval for mu and find it to be 1.33 to 4.67. So they already do this for us. So we just have to know, are we going to reject or fail to reject? Well, 1.33 to 4.67, is this inside of that interval? It's not. 5 is outside of that interval, so we should reject the null hypothesis, okay? Now, you gotta be careful. B is not the correct answer because that says H of A. We're not interested in a p-value, okay? The p-value, we don't know what that is. We're not calculating that, but this is trying to make you think of alpha, so it's not that, okay? The best answer is A, reject this, okay? That is the best answer. 6, you test the hypothesis. So I'm gonna have you answer it. This is probably, of the 4 questions, the most challenging, I'd say. There's a lot to think about here and a lot of ideas to connect, okay? So I'm gonna go ahead and pause and let you guys try to answer it. Okay, so let's talk through it. You test the hypothesis mu equals 1 and against the alternative and obtain a p-value of 0.022. So that's your p-value, 0.022. Which of the following must be true? Okay. So we have to read through all of these and we have to carefully think about what it means and what we've described on this page about how these confidence intervals relate to the p-value and alpha. All of that has to tie together, okay? Let's see if you made sense of this. I think PlayPosit tells you the correct answer, right? So start with the first one. A 95% confidence interval from you will include the value 1, okay? Well, 95%, if we say 95%, and this will go for both of them, what is alpha? Alpha would be 0.05, right? And if we compare the p-value to this, p-value is lower than that. And if the p-value is lower than that, that means it's significant. And we would reject the null hypothesis if that happened, okay? Which means if we think about the confidence interval, if the p-value is lower, it will not include the null hypothesis. If the p-value is less than alpha, it's not going to include this. So this can't be true, okay? Can't be true. I want to give a little more descriptor here. That can be kind of tough to follow. Here is the 1, right? 1. This interval, if we're saying p-value is less than this, that means the interval, whatever it is not going to contain it. It's outside of it, okay? This line, it might be close, but it's not going to contain 1, okay? Let's look at this one. 95% confidence interval from you will include 0. We have no idea about that. This, all we can say is if it's going to include the parameter or that null hypothesis or not. That's it. We don't know anything about another value 0. 26 minutes. This is, I said it was going to be short and I was wrong. Next, 99% confidence interval from you will include the value 1. Okay, so 99% means we change alpha. So let's do this for C and D. 99% means alpha is 0.01. And now we compare that to the p-value. P-value greater than or less than this? Well, it's greater than this 0.01. So when we change that alpha level or the confidence level, interval wider, will it include 1? It should, because the p-value is greater than this. That means we fail to reject HO, which means it's in that confidence interval. So right now, C is true. We, again, on D don't know anything about 0, so that's going to be the explanation for that. Okay, hopefully that's making sense. Again, that's probably the most difficult one to think about. We really had to tie a lot of concepts together there. Last one. An agricultural researcher plants 25 plots with a new variety of corn. The average yield for these plots is 150 bushels per acre on average. Assume that the yield per acre for the new variety of corn follows a normal distribution with an unknown mu, and that a 95% confidence interval to be 150 plus or minus 3.29. Now, we need to go ahead, just like we did here, and we want to create that interval notation. So going down, it's 146.71. That's the lower boundary. Upper boundary is 153.29. Okay, that's what our interval is going to be. When we look at that, we got to compare it to all these answers. I don't know if I paused the video, but I'm gonna in the video I know I'm gonna have done it. Okay, so let's talk through it. This isn't true. We don't need a sigma to do that, by the way. So that one, E, is an easy eliminated answer. But let's compare these. So 150, 150, 155, 155. So these two, it should include the value, meaning it won't be significant. So looking at this, 95% confidence interval, 150 is in it, so it's not significant. So this isn't true. Significant? Nope, that's not true. Okay, now 155 here. 155. Test of the hypothesis. Okay, so now we got some different alpha levels. Look at that. 0.1. We can't use 0.1 as an alpha level because our confidence interval is 95%. So that alpha level is what makes D a bad answer. The hypothesis, or the mu in the hypothesis, null hypothesis, is in or outside of this interval. So that means it has to be significant, but we have to make sure that we understand how that confidence level affects that alpha level. So it's C. Okay, we're stopping there, 30 minutes exactly. Hopefully that made sense. I know there's another question I think that follows this one up, number 38 on here. Dual credit or AP you've got still, you can do 45, 49. So those are two more confidence interval questions you can practice with, and I might have some more practice out to work with that. Okay, so I'm going to stop there.